Thank you very much for these insights. We open the discussion.
Yeah. Professor Phillips.
Well, that was a lot of information. And I'm guessing that one of the reasons why you've presented us with so many different schemes for the reduction of hydrogen is because it's not yet clear which is the best. And what I'm wondering is two things. What kinds of issues are still open that will need to be decided in order to settle on a good scheme, and how much better would that eventual scheme be, say, than simply growing plants and burning them?
Right. Well, as far as reduction of water to hydrogen is concerned, photochemically, I think we have reached a stage which are more or less as final as it can be. The real problem is keeping the electron and hole separate, not allow the recombination. And I think we have succeeded in that by the right kind of heterostructures, and I think there is no longer such a problem. But that is why we got rid of that and used the dye-sensitized thing, where the molybdenum sulfide sheets, the nano single layers, do a job. And between these two methods, photochemical methods are quite safe. But what I did not mention, people say, why are you doing all this? Why don't you do photovoltaics? After all, sunlight, you do solar photovoltaics, use electrochemical production of hydrogen using sunlight, photovoltaics. Well, in fact, my friend from Israel recently who came, he asked me that. But unfortunately, you can't do electrolysis. Electrolysis is very difficult because of the overpotential problem. So there's a lot of work now we are doing on the overpotential problem, getting rid of platinum catalyst. Sunlight, more or less, we have reached a stage which is reasonable. Thermochemical is not yet tested. We have only done laboratory scale. Many people have done photochemical also at laboratory scale. Nobody has put up. Just the first plant is being put up on a photochemical hydrogen and carbon monoxide production recently. So I hope it will be successful, large scale production. Laboratory scale is quite successful. As you know, the Berkeley people also showed that hydrogen comes out quite nicely in their catalyst quite effectively. I'm quite hopeful as far as production of hydrogen is concerned, also production of carbon monoxide is concerned by both photo and thermochemical means.
As we are discussing chemistry here within the frame of sustainability, I have one great worry which I would like to share with all of you, and I cannot think about somebody more knowledgeable than CNR Rao to answer this question. Every year there are more than 300 million tons of polymers produced, and less than 10% are biodegradable, meaning that every year we add hundreds of millions of tons of polymers every year. And something must happen. And the only way I think we can get rid of it is through some catalyst that would split it. I'm just worried about it. This is one problem which is never discussed, but it's important. I thought that Rao is the ideal person.
I agree with you. So, by the way, many countries, recently I've been to a country in Africa, I was amazed they made a country plastic free. I'm talking about Rwanda. It's such a clean country, it's unbelievable. I wish we all had to learn something from an African country which is much cleaner than many European and Asian countries. So they made a very completely plastic-free country. So I think we use too much plastic and we shouldn't use it. That is a different matter. But I have no solution on how to solve the problem.
Professor Rao, your result of water splitting is very exciting. I'm wondering, at the present time, if you look at the photovoltaic generation of electricity, you can pin down how much would it cost and last for 30 years.
Correct.
And activity only reduced by 3%, and you can estimate the cost of generating electricity. In your water spreading, could you put the cost? And how long will
Yeah, I agree with you. As you know, in India, thanks to China, which has dumped so much of silicon cells all over the world, photovoltaics have become, electricity has become as cheap as any other electricity so now. But that is different from, as you know, what I'm talking about for hydrogen for some other purpose. The cost I cannot put yet. This is what I mean. This has to be worked out. In fact, Dr. Phillips' question is also valid in this. We have not yet worked out these processes to make a large-scale plant, and how much it may cost has not been done. It has all been done on simple laboratory scale, and we're yet to find out. As I told you, the first plant I know is being put up using something similar to what I talked about. I don't know the cost right yet.
So I don't see any more questions at this point. That means we certainly have to thank our two speakers.